Hello everyone. In this video, we are going to start with precedented binary search, and this is the most important topic in binary search. Like जो questions आपको मिलेंगे वो यहीं से होने वाले हैं और एक एक चीज मैं डिटेल में बताऊंगा like from my experience what I learned, what are the patterns to look for, and once you get confident with this type of questions, then you can say that you can approach about 80% of the questions in all the competitive exams, and rest all depends on your practice. So let's start. So what are the patterns to look for? It may seem to you something weird like what I wrote over here, but yeah, this is the thing like we are going to discuss. Whenever you find something like this, like for some of functions, for some conditions, you are getting true. For some values, like there are some conditions, and you put some value over there, and you see that when you were increasing the value from its minimum point, you were getting the condition as true. But after some point of time, you get false, and once you increase the value from there, you are always getting false. This can happen. Similarly, you can see that when you were on the starting of your value, you got the condition as false, and you were getting false once you were increasing your value. But at some point of time, you got true, and from that point, every time you increase the value, you got the condition as true. So if these two are the cases, then in both the cases, you can apply binary search. Like in this type of questions, we are always required to find out the first false or the last true, or the last false and the first true. These are like the most important questions. This can be tricky at times, like you need to identify the questions, but once you are able to identify, once you are able to discover the condition, then you can easily encounter the problem. We will see this, we will see the questions of this, and you will get familiar with that. Okay. So, yeah. Now let's find out the square root of a number. Uh, Square root निकालते हैं. We know that we have a square root function, right? If we find out the square root of n, we always know we have a function. This will return us as a function. Like if we put int a as square root of n, this square root of n will be rounded down. For example, square root of 5 will result to 2 if we use int a, and square root of 6 will result to 2, and so on. Square root of 9 will give us 3, like this. But we need to find out the square root of n rounded down to an integer using binary search. So how we can do that? What is the condition you feel like you are getting as true? Let's see. Let's suppose you have some element x. Can you say that if x is that number which we need to find out, then x multiplied by x will always be less than or equal to the required number? Can you say this? Like if we need to find out the square root of 6 and we take the x as 1, then 1 into 1 must always be less than equals to 6, right? Like let's say 2. So 2 multiplied by 2 must always be less than equals to 6. Similarly, if we talk of 3, then 3 multiplied by 3 is not less than equals to 6. It is actually greater than 6, right? So 3 can't be the answer. So like बाइनरी सर्च में क्या करते हैं, हम पहले स्टार्टिंग इंडेक्स को इनिशियलाइज करते हैं एंड देन एंडिंग इंडेक्स को इनिशियलाइज करते हैं. कैसे इनिशियलाइज करते हैं? स्टार्टिंग इंडेक्स इज द मिनिमम परमिसिबल वैल्यू. So if you are required to find out the square root of a positive number, so can you say that the minimum permissible value is 1? Similarly, if you're required to find out the square root of a number, then can you say that the maximum permissible value is n? The value can't be more than n, right? Square root of the number उस number से तो ज्यादा नहीं हो सकता ना, या तो वो number होगा, for example in case of 1, square root of 1 is 1, या फिर वो number से कम होगा. यही दो cases possible है ना. So yes, these are the two possible values. So we will initialize our starting index with 1 and ending index with n. So our answer lies between starting index and ending index. This is the first thing which I wrote in, I think, like the first video I made. So like this is very important. Your answer will always lie within starting and ending index. Now you see like how we are getting the answer. Let's suppose we take a number 20. We initialized our starting index with 1 and ending index with 20. Now if you check for some numbers, if you start writing down the numbers 1, 2, 3, 4, 5, 6, 7, 8, so on up to 20. And if you check the condition, like for the number to be true, like if the condition, we make the condition like x multiplied by x is less than equals to 20. If we make the condition like this, how many of the numbers will pass this condition? 1 will return true because 1 multiplied by 1 is less than equals to 20. 2 will return true, 3 will return true, 4 will return true. But when you come on 5, 5 multiplied by 5 is equals to 25, which is not less than equals to 20. So you will get false. And every number after 5, you will get the condition as false, right? So isn't it the same thing we discussed in our last slide? Like you are getting true for some conditions, you are getting false for some condition. And in this question, we are required to find out the last true condition, right? The last true. Because this is our answer. 4 is our answer. Once we find out the square root of 20 and round it down to an integer, we will get 4 as our answer, right? So we need to find out 4. So let's suppose we have our starting and ending index. We find out the mid, which is nothing but starting index plus ending index minus starting index divided by 2. Now, what are the possible positions of mid? Mid can either come in this part, or mid can like this part, false part, or the mid can come in true part. You can keep one answer. You can keep one answer, which will be the answer which we are going to find. If you find out that, okay, the mid lies in part which is giving true. For example, if your mid is 3, so 3 will give us the true condition. So this is a possible answer. So what you will do is, you will substitute the answer as mid, that is 3, and you will simply move your answer, like move your starting index to mid plus 1. Because let's suppose you are in this position, like your mid is this. You found out true, but you need to find out the last true. So you will check in right part of this true that whether some more truths exist or not. So what you will do is, you will put your starting index, you will shift your starting index over here. Similarly, let's assume that you got your mid in some position over here where you were getting condition as false. So in that case, yes, this is not our answer. So what we are going to do is, we are just going to move our ending index to mid minus 1. So if we just write this simple codes, we will be able to find out the square root of an integer, square root of a number rounded down to an integer. Let's code it down once. We took the number whose square root we need to find out. We initialized our starting index to 1 and ending index to n. Then we simply did binary search, while starting index less than equals to ending index. And mid is nothing but starting index plus ending index minus starting index by 2. Now, if that mid element satisfies the condition that mid multiplied by mid is less than equals to n, in that case, we are going to keep one answer variable. We are going to substitute our answer as mid and search for a better answer. Like we need to find out the last true, right? We encountered a true over here, but we want the rightmost true. So we will shift our starting index to mid plus 1. And if this is not the case, the condition is false. So we know this is not our answer. Our answer will lie in the left part, so of the mid. So we will just shift our ending index to mid minus 1. And after doing all this stuff, we will simply print our answer. So if we like take our number as, let's suppose, 8, so we should get our answer as 2. Let's check it. Yes, we are getting as our answer as true. Let's suppose we take the number as 9 and check it. We are getting our answer as 3. So this is how you can do a precedented binary search. You can just find out some conditions where you can find out like true, 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 false, 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 or false, 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 true, true, true. And in that kind of questions, you need to find out the last true or the first false, or the last false or the first true. This is very important pattern. Like once you start solving questions of binary search, you will see that yeah, many questions are there where you are getting this pattern. We will solve questions. Then you can get like more confident with this strategy. Now you can see like how we will identify the question. Whenever you find out like you need to maximize the minimum value, you need to minimize the maximum value. The constraints given is something like n is less than equals to 1 is 6. If these are some conditions, then you can say yeah कि हम इसमें binary search लगा सकते हैं. I am not saying that in this questions will only be solved by binary search. There will be it may be that these questions cannot be solved by binary search, but these are the possible cases. Whenever you are required to maximize the minimum value, minimize the maximum value, the constraints look like something this, like something this. So in that case, you should give a try. Like, chalo binary search to try kar lete hain. If you are not able to find any other approach, binary search, like you can apply that. And once you practice some questions, you will get familiar with the type of questions binary search come up with. And yeah, it is not like hard and fast. Like you will get through. This is the only pattern which comes with binary search. You need to find out the conditions, and then you need to find out this like edge cases, the first false or the last false, and so on. So this is the pattern. We will see the questions in the coming videos. Uh, okay, so for this video, let's stop it here. Thank you. Meet you in the next one.